Good morning, pre-cal students. Welcome to class today. Hope you guys are doing well. Hope you're ready to learn some math today. Let's go ahead and go over some announcements and then we'll get started with today's notes. Hope you guys are doing well today. There will be a test on Monday, and so if you're not going to make it to class, be sure and let me know no later than Sunday, please. So, test on Monday. So we'll have a review sheet on Friday. And sorry guys, my throat's still bothering me. um, and so what I told you guys is I'm not upset that you guys have not been watching the review sheets, but there's no need to make a video if if it's not going to be watched. So here's what we're going to do. When I give you the review sheet, I will give you the answers to the evens, and of course you have the answers to the odds in the back of the book. So if you choose to work on the review sheet Friday, Saturday, and Sunday, you will be able to check all of your answers and know right where your questions are. If you don't, then that's fine too. But on Monday, we'll go over y'all's review sheet. When you leave class on Monday, I will make a note of the problems that we did not get to, and I will probably make that video right then as soon as you leave and post it. So within the next hour after you leave my house on Monday, you will have that video to watch, okay? So that's what we're going to do. Call or email if you have any questions on that. And then remember your integrity sheets. Be sure and stay up on those so that you're not getting low grades there. Once you come in Monday, they've got to be completely caught up, okay? Now, look, guys, I'm really sorry. I cannot shake this thing for anything, so I'm going to be drinking a lot during the video, and that's just how it's going to be. So I apologize, but I wish I could get rid of this thing. But it is what it is. Okay, well, let's get started. And please get your notes out, your notebooks, pens, pencils, and here we go. Yesterday, we looked at slope. Today, we're going to apply this knowledge to real life problems. Yes, that means word problems. I know you guys get really sarcastically, I know you guys get really excited about that. Today's teaching video is going to be very short. However, the reason for this is because I want you focusing on the word problems that are in the homework. I've given you 9 of them, and you really need to do them diligently. Check your answers in the back of the book, and then if you miss one, watch the video to find your mistake. That's very, very, very important. Slope word problems is your heading. The lesson is 1.3, and if you keep track of the date, which I encourage you to do, today is the 19th. Slope word problems, lesson 1.3, and today is the 19th. Let's continue on. We'll be using our books a lot today for this session, so go ahead and get your books out. Now, you guys know I go fast, so pause the video when you need to. I'm going to go ahead and get started after I get another drink here. Okay, here we go. Page 96, example 3. Please turn over in your books to page 96, example 3. We're going to look at 3 problems today. 1, 2, 3, actually 4, sorry, 4 problems, and then we'll give your homework to you to work on, okay? All right, here we go. Page 96, example 3. Construction laws regarding ramps for the disabled state that a vertical rise of 1 must have a horizontal run of 12 feet. What is the grade or slope of such a ramp? Now, hopefully you understand what they're saying. A ramp, in order for it to be wheelchair accessible, really shouldn't be too steep. That's dangerous. And to be honest with you, probably if it was too gradual of a slope, that would be okay. I don't think there would be any problem with that if you made your slope really, really gradual. But what they're saying here is the steepest it can be is every time you go up 1 foot, you have to have a horizontal of 12 foot. So here's your ramp going upward like this. And then what you do is you draw that. Remember how you draw that imaginary right triangle I've taught you to do? What it means is And now you see where slope fits in. If the change from here to here is 1, then the change from here to here, the distance, if you will, has to be 12. That's what they're saying. It cannot be any steeper than that, okay? So, look what they're asking you. What is the grade or the slope of such a ramp? Oh my goodness, rise over run. We're finished. Now back it up again and watch the video if you need to, but that's it. I mean, the slope of any line or any grade or any hill is the rise over the run. And so that's the steepest that a ramp can be on a disabled, wheelchair accessible type of slope like this, okay? All right, let's continue on. The percent of travel bookings online has increased from, and here we go, I would write this down if I were you, in 1999, it was 6%, and then in 2007, it had jumped quite significantly to 55%. The graph below illustrates this trend. Find the average rate of change in percent of travel bookings from 99 to 2007. Okay, they look at this as like slope. Just like in slope, now listen to me guys, just like in slope, you found the changes in your y's you subtracted per or over your changes in your x. The reason I use the word per, just like miles per hour, when you're traveling down the road in your vehicles. Per means fraction, miles per hour, okay? So, slope is your change over your change. This is your change in your y's per every change in your x's. And so that's why we're looking at this as kind of like a slope word problem. Now, notice the question. They want us to find the average rate of change in the percents. So, my first question to you, are we going to have a positive or a negative change? Well, you tell me. We started in 1999 at 6%. In 2007, we went up, keyword, up to 55%. So if we're increasing, it is going to be a positive slope. Okay? Now, let's see how much of an increase we have here. First of all, we go from 55% to, we've gone from 6% to 55%. Now, is that not a 49% increase? So I'm going to put the number 49. That's the change. That's the change. From 6 to 55 is a 49% change. And that happened over the course of how many years? Well, we started in 1999 to 2007, subtract, and you get an 8. There you go. You just found the average rate of percentage change per year. Here's the difference in the percentages. Here's the difference in the years. And if you'll look in your book there, you'll see the answer. They wrote it as an improper fraction. So they wrote 6 1/8% change per year. And I guess you could type that into your calculator and get out a decimal. I would have no problem with that. And so your answer for decimal form would be 6.125 change per year. Okay? Percent, actually. Sorry about that. 6.125% change per year. All right? Watch it again if you need to, but that's all we're doing is we're finding the change. All right? The rate of change per something. All right? Let me grab a drink here. We'll take a look at number 5. In 2002, 57% of beverages sold in high schools were carbonated soft drinks. This percent decreased to 44.9% in 2005. Find the average rate of change in the percent of beverages. Okay, well, let's take some notes here. In 2002, 57% of the beverages were carbonated. In 2005, that had dropped to 44.9%. Now, first of all, let's find our rate of change. Or in other words, if we were going to write a linear equation, we would call it our slope. We really would, because the rate of change is your slope. It doesn't always have to be rise over run. Please keep that in mind. Now, let's find our rate of change here. First of all, we went from, in 2002, we started at this percentage, and in 2005, we were down to this percentage. So with that in mind, your slope would be negative. Okay? All right, let's continue on. Now, let's find our difference in our percentages. The difference between 57% and 44.9% is 12.1. That's the total change over all these years. But now let's divide that by 3, because how many years were there here? 3 years. So we're going to find the average rate of change in percentages per year. So this is the total amount of percentage of change. This is the amount of years that it took place. And so if you divide this out, you would get approximately 12.1 divided by 3 is approximately 4. So it's a 4% change per year. And that's just about right. A 4% change per year. Hope this is making sense. Watch it again if you need to, okay? We're dealing with finding differences, rates of change per years or per something, okay? In all of these different problems. Okay, let me grab a drink and we'll look at number 6, and we're finally finished. All right, number 6. An anthropologist can use linear functions to estimate the height of a male or female, given the length of the humerus, the bone from the elbow to the shoulder. So in other words, let me explain that. If they're digging and they find a bone that has a certain length, the humerus bone, then they can tell you the height of whatever this creature was, okay? And so if they find the length of a bone, they can tell you the height of the animal. The height in centimeters of an adult male with a humerus length is given by this function right here. Sorry for all the stuttering I'm doing. I apologize. I do know what I'm doing. I'm just kind of reading here and trying to think at the same time. All right, so this model here, let me explain what this model does. 2.9x plus 7064. Okay, now what this model is, and you need to learn to read this on your own. It says the height of an adult male with a humerus of length x. Okay, so here's what this model does for you. If you find a male humerus bone and you plug the length in right here, you will get out the height of the male. The height. Okay? That's what that's saying. Hope that makes sense. Now they also have a model for a female, and the model for the female is this right here. And again, it's the exact same idea. If you find a humerus bone that belonged to a female animal, you can plug it in for the X right here, and you will get out how tall or the height of the female animal. Now the problem reads as follows. A 26 centimeter humerus was uncovered in a ruins. So we have this right here, a humerus bone that has a length of 26 centimeters. Assuming it was a female, how tall was she? Now the next question says, I hope you're following along, what is the domain? We'll talk about that in a second. Let's take this one step at a time. First of all, how tall was the female? Well, obviously, if we're dealing with females, then we're going to be dealing with the equation or the formula that's dealing with females. So I'm going to get rid of this information right here. Well, I was going to anyways. And here's the formula we're going to use. So where the x is, I'm going to substitute 26. 2.75 times 26 plus 71.48. Now I could get out my calculator and type it in, but if you look in your book, they do the work for you, and you get out 142.98. So that's the height of the female animal. Pretty cool. So you knew the length right here of the humerus bone, and you could figure out the height. Okay, easy enough. They give you a model, you plug in a number, you get out a number. Pretty simple. But now look at the last question. The last question is, what is the domain of this function? Now guys, I hope you remember we studied this a couple days ago. I don't know, 2, 3, 4 days ago. And when you look at this, you don't see any fractions. You don't see any square roots. So you're like, well, Mr. Earhart, you can put anything in for x you want to. You taught us that. The domain is all real numbers. Yes and no. Let me explain. In a normal situation, let me get a drink here real quick. In a normal situation, that would be true. But now that we're studying this equation in light of what it does, think about it. What could you not put in for x? Let me give you a hint. How could you have a length of a bone that's 0? That's impossible. How could you have a length of a bone that's -6 centimeters? That's impossible. Now normally in a function like this, if you didn't have any of this information right here, that you were dealing with animals, then you would look at this and you would say the domain is all real numbers, and that would be fine. That would be the answer, because you are allowed to put anything in for x that you want to. But because it's a word problem and we're dealing with length of bones, then think about it. There's no way that a bone can have a 0 length, and there's no way a bone can have a negative number. It's not going to happen. So think about a number line. Here's 0. You're going to want everything to be greater than 0. Okay? Not including 0, because you cannot have a length of a bone that's 0. So you could write this with words. You would say all real numbers larger than 0. Or you could use inequality. So you would say x is greater than 0, not equal to, just greater than. Or you could use interval notation, parentheses, because it's not equal to 0, comma, all the way to infinity. Okay? Any of those is fine, but that would be the domain. Okay, I warned you the video was short. Let's really get to work on the homework now, okay? You have 9 problems. I want you to work diligently on these. I want you to have the back of your books marked, check your answers as you go, and when you're finished, if you have any questions, watch the video on the ones that you missed, okay? Have a good day. Call or email if you have any questions.